So you're looking to get a handle on something important, right? But wading through tons of articles, it can feel like a massive time sink.
Definitely.
Consider this your fast track. Today on the Deep Dive, we've grabbed all those sources you shared on the circular economy in the textile world, and, well, we've boiled them down to the key stuff you need. It's your quick way to get seriously informed.
Exactly. And our focus today is really understanding this big shift, in how we think about clothes. Moving away from that old take, make, dispose model to something much more sustainable. We'll look at how a circular economy based on reducing, reusing, recycling gives us real answers to the environmental and economic problems we're facing.
And the idea of actually turning waste into something valuable.
Yeah, that's a potential game changer. Huge possibilities there.
And just to grab your attention straight away, here's a fact that really jumped out at me, the textile industry. Up to 10% of global carbon dioxide emissions every single year.
It's huge.
That's over 1.7 billion tons. Okay, so let's dig into this linear problem that's causing those kinds of numbers.
Right. So the traditional way the textile industry works is what we call linear. It's a pretty straightforward path,
Yeah.
You take raw materials, make them into textiles, clothes, distribute them, people buy them, wear them.
And then
chuck them out. Exactly. They end up as waste, usually landfill, sometimes incineration.
And looking at the data, the negative impacts of this are pretty striking. Beyond that huge carbon footprint we just mentioned, the industry is a big player in industrial water pollution, something like 20% globally.
Yeah.
A lot of that from dyes, right?
That's right, the dyes and finishing chemicals.
Yeah.
And it doesn't stop there. You've got microplastic pollution in the oceans, maybe 190,000 tons a year just from textiles.
Wow.
And then just the sheer volume of waste. About 92 million tons of textile waste generated every year. It's truly enormous.
Which brings us to fast fashion, doesn't it? It feels like this whole trend of rapid, cheap, trendy clothes has just poured fuel on the fire.
Absolutely. Fast fashion with its, super quick production, really short trend cycles.
Things are out of style in weeks.
Exactly. And it encourages buying more and more. Global clothing consumption up 400% in the last 2 decades alone.
400%.
And get this, fast fashion brands now make 50% more items than they did back in 2000. So that's about 100 billion new garments every single year. That
number is just staggering. So we're buying more, wearing it less, throwing it away faster. And what's worse, our sources pointed out that the low quality of a lot of this fast fashion stuff actually makes it harder to recycle anyway.
Exactly. The materials, how they're constructed, they're often just not designed for durability or, to be easily taken apart and reused. It's a massive hurdle for any kind of circular thinking.
Okay, so if the linear model is the problem, what's the circular solution then?
Well, the circular economy, or CE, is what everyone's talking about as the sustainable path forward. The core idea is cutting down waste by really focusing on designing products differently, designing them to last longer, to be reusable, repairable. And then, crucially, when a product finally does reach the end of its life, the priority is recovering the materials and recycling them.
So it really boils down to those 3 R's. Reduce, reuse, recycle?
That's the heart of it, yeah. Use fewer resources in the first place, keep products in circulation as long as possible, and then when they really can't be used anymore, turn them back into valuable stuff.
And the upside isn't just environmental, is it? I mean, obviously using less water, fewer resources, less energy, that's a huge win for the planet.
Precisely. Huge environmental benefits. But there are also really significant economic pluses.
Like what?
Well, if you start looking at waste as a resource, you can actually turn it into wealth. Think recycled yarn, regenerated fibers, even things like biofuels.
Right.
This creates potential for completely new revenue streams, new businesses. It can genuinely boost a country's economy. There's actually an estimate that shifting fashion to a circular model could inject something like $192 billion into the global economy by 2030.
$192 billion. That's a serious number. That's not just pocket change. That represents potentially whole new industries built around keeping textiles going, recovering value.
Exactly. It's a powerful economic driver.
And it's interesting how this all ties into the bigger global sustainability goals, too.
Yeah, absolutely. Implementing a circular economy in textiles really aligns up with the UN Sustainable Development Goals, the SDGs.
Which ones specifically?
Well, it directly helps with goals around responsible consumption and production, obviously. It encourages economic growth through innovation, and it plays a big part in protecting the environment by cutting pollution and conserving resources.
Okay, so we get the what and the why, the linear problem, the circular solution, but let's get into the nitty-gritty of the textile supply chain itself. Where is all this waste actually happening? I mean, to really get where we can make changes, we need to follow the journey of our clothes, right? From, like, the field or the oil well to the bin.
That's a crucial question. And the answer is, it's complicated. The global textile supply chain is incredibly spread out, geographically complex.
Yeah.
It starts with sourcing raw materials, could be growing cotton, could be making synthetic fibers from petroleum. Then it moves through manufacturing, shipping, distribution, retail, and it's worth noting, garment production has increasingly shifted to lower wage economies over the decades.
It's a truly global maze, isn't it? And I guess every single step has its own environmental price tag.
Absolutely. Let's walk through some key stages. First, fiber production itself. And here, there's a big difference between natural fibers, like cotton, and synthetics. And remember, fashion is the biggest user of fiber globally, about 60% of all fiber consumption.
60%. And synthetics like polyester, they dominate now, right?
We really do. And while they have certain advantages, making them is heavily reliant on fossil fuels.
How much?
Estimates are around 98 million tons of oil used every year just for the fibers, the dyes, the finishing treatments.
Wow.
Plus, synthetics are, not readily biodegradable. They're a major source of microplastic pollution. Studies show washing a load of polyester can release maybe 700,000 microplastic fibers.
In one wash.
In one wash. And their carbon emissions during production tend to be higher than natural fibers, too.
Okay, and on the natural side, cotton always gets flagged for water use.
It does, yeah. Cotton cultivation accounts for a huge chunk, somewhere between 88% and 92% of the entire textile industry's water footprint.
That's massive.
And it can lead to really severe water scarcity in growing regions. The Aral Sea crisis is often cited as a stark example linked to cotton irrigation.
So right from the very beginning, the impacts are huge. What happens next in the chain?
Okay, so after fiber production, you've got yarn manufacturing spinning fibers into yarn, then fabric construction, knitting or weaving.
Okay.
Then comes what's called wet processing. This includes things like scouring, bleaching, and critically dyeing. This stage is incredibly energy and water intensive and a major source of chemical pollution.
Right, the dyeing again.
Then you have garment manufacturing, cutting the fabric, sewing it together, adding trims like buttons, zippers, labels.
And then somehow these finished clothes have to get to us all over the world.
Exactly. Logistics and transportation are a significant part. And the rise of fast fashion and e-commerce means more reliance on air cargo, which has a much higher carbon footprint than, say, shipping by sea.
Right.
And finally, you reach retail and the end-of-life stage, where, as we discussed, most items currently end up landfilled or incinerated with very low recycling rates.
It really is a complex chain with impacts all along the way. You mentioned some numbers earlier about export value and fiber production growth.
Yes. Global apparel manufacturing export value is around $489.6 billion. Top exporters are China and the EU.
Okay.
And worldwide textile fiber production has just exploded. It went from about 23.9 million metric tons in 1975 to 124 million metric tons in 2023.
That growth is just phenomenal. It really shows the scale, doubling garment production in just 2 decades. That's not just more clothes, it signals this fundamental shift towards disposability that, well, the planet just can't handle.
Precisely. And you also asked about chemicals earlier.
Yeah, the number sounded huge.
It is. The industry uses over 15,000 different chemical substances throughout the process.
15,000?
Yeah. Everything from pesticides in cotton. Farming cotton uses about 6% of all global pesticides.
Wow.
To lubricants, dyes, sizing agents, finishing chemicals used during manufacturing.
And these chemicals aren't exactly benign, are they?
Unfortunately, no. Many pose significant risks to human health, to the environment. Some are carcinogens, some are reproductive toxins. Many persist in the environment and bioaccumulate.
Like what?
Well, things like fluoropolymers used for waterproofing, for example. They've been found even in remote Arctic regions. It really highlights the urgent need to shift toward safer, more sustainable chemistry in textile production.
Okay, so we've sketched out this linear system, its global reach, its impacts. Let's zoom in now on the waste itself. What exactly is it and where does it come from? I mean, the waste before we even buy clothes sounds significant, but the mountain of stuff discarded after we're done with it seems like the bigger challenge.
That's a good way to put it. We generally talk about 2 main types. pre-consumer waste and post-consumer waste.
Okay.
Pre-consumer is waste generated during manufacturing and distribution. Post-consumer is what happens when we, the consumers, decide a product is at the end of its life for us.
Right.
And it's important to remember, textile waste is usually pretty heterogeneous. It's often a mix of different fibers, natural, synthetic, plus non-fibrous bits like buttons, zippers, sequins. That mix makes recycling inherently trickier.
Got it. So let's start with pre-consumer waste. Where does that typically arise?
Pre-consumer waste, which can be anywhere from 10% to maybe 30% of the material used in production.
That's much.
Yeah, it comes from a few places. Production errors, fabrics with flaws, color mismatches, things that don't pass quality control. Then you have cutting room scraps, the bits left over after pattern pieces are cut. And a big one is unsold inventory, often called dead stock. Clothes made but never sold.
And we've heard stories about that dead stock, haven't we? Brands ending up with mountains of unsold clothes? Sadly, yes. There are estimates that maybe 30% of all clothing produced globally never gets sold. One famous example was H&M back in 2018, reportedly holding $4.3 billion worth of unsold stock. And they faced criticism for allegedly incinerating some of it.
Burning brand new clothes, it just sounds incredibly wasteful.
It is. And it really highlights the scale of the overproduction problem inherent in the current model.
So what typically happens to this pre-consumer waste?
Ideally, it can be managed better, discounted sales, or more circularly recovery and recycling into new materials.
Okay. Now let's shift to that huge mountain of post-consumer waste. What's driving that?
Post-consumer waste is largely driven by, well, declining product quality and the deliberately shortened lifespans associated with fast fashion.
We just don't expect things to last.
Exactly. It leads to frequent disposal, sometimes after just a few wears. Studies suggest maybe a third of garments are thrown out within the first year of purchase.
Globally, remember those 100 billion garments produced annually? Well, about 2.1 billion tons get discarded each year. And projections suggest that could rise to a staggering 148 million tons by 2030 if we don't change course.
Those numbers are just terrifying. Are there specific countries where this problem is particularly bad?
Absolutely. The U.S. is a major contributor, about 11.3 million tons annually. That's over 37 kilos per person, and makes up over 5% of all their municipal solid waste.
Wow. What about elsewhere?
Canada sees textiles making up 5–10% of landfill content, mostly clothing. Europe generates around 5.8 million tons a year, about 6% of its solid waste, but the recycling rate there is surprisingly low, only about 26%.
Only 26%.
Yeah. Italy is the biggest contributor in the EU, then Germany, France, the UK. Those four account for over half the EU's total. The UK figure is around 30 kilos per person per year. Australia estimates the economic loss from post-consumer textile waste at over $500 million Australian dollars annually.
And China, as a huge producer, they must have a massive waste issue too.
Indeed. China landfills an estimated 26 million tons of textile waste each year. That's nearly 14% of their total waste. The environmental consequences of landfilling on this scale, greenhouse gas emissions, resource depletion, are immense. It just underscores the urgent need for circular solutions globally.
It's crystal clear we need a massive shift. So what strategies are actually being proposed or implemented for this circular textile economy?
It really requires a multi-pronged approach. Strengthening the recycling infrastructure is key, having the facilities to actually process this waste.
Right.
Promoting sustainable consumption is another big piece, encouraging people to buy less, choose durable items, care for them longer.
Changing habits.
Exactly. And then there are policy tools, like implementing extended producer responsibility, or EPR.
What's that exactly?
Basically, it makes the producers, the brands, more responsible for the end-of-life management of their products, financially or operationally.
Ah, okay. And technology must play a role too.
Definitely. Advanced sorting technologies are crucial, things like near-infrared spectroscopy, optical sorting, even AI, to efficiently separate the different fiber types in mixed waste streams.
Because that's a big challenge, right? The mixed materials.
Huge challenge. We also need investment in large-scale recycling facilities and supporting the growth of secondhand markets, resale platforms, rental models. All are part of the solution mix.
It feels like there's a massive economic opportunity being squandered here, too.
Absolutely. That figure of $500 billion lost globally each year due to inadequate recycling and clothes being underutilized, that's enormous. Better waste management isn't just good for the planet. It's a significant economic lever we're not pulling effectively right now.
Okay, so let's dive deeper into recycling itself. It seems central. What are the actual technologies being used or developed to turn this waste back into useful stuff? Let's start with the more Straightforward methods, perhaps. Mechanical recycling.
Right, recycling is absolutely core to the circular economy vision. It's about taking waste and transforming it into new products, reducing environmental impact, conserving resources. For textiles, we generally see four main categories of recycling tech: physical or mechanical, thermal, chemical, and biochemical.
Okay, physical, mechanical first. What does that look like?
Mechanical recycling basically uses physical force machines to reprocess the waste. The typical steps are sorting the textiles, cutting them into smaller pieces, and then shredding or defibrillating them back into a fibrous mass.
Like pulling them apart?
Kind of, yeah. This fibrous material can then be carded and spun into new yarns or used in non-woven applications.
So what kind of new products usually come from mechanical recycling? Is it high quality?
Generally, mechanically recycled fibers tend to be shorter and perhaps weaker than virgin fibers, so they often end up in, let's say, lower grade uses. Things like filling for upholstery, automotive insulation, soundproofing, building insulation, cleaning wipes, that kind of thing.
So not necessarily back into new clothes.
Not always directly, or often blended with virgin fibers. But there's research improving this. For instance, studies have shown recycled cotton fibers from pre-consumer waste can be successfully blended with virgin cotton. Maybe up to 20% recycled content to make yarn for t-shirts or sweatshirts, sometimes even improving strength. Similar work's been done blending recycled acrylic with virgin acrylic.
That's promising. I think I read something about using this stuff in construction, too.
Yes, that's a really interesting area. Researchers are exploring using textile waste mixed with binders to create composites, even brick samples with potentially better insulation properties. Recycled PET fibers can reinforce concrete. Shredded textiles are being looked at for things like textile reinforced concrete, or even thick ropes for things like slope stabilization.
Clever uses.
And for some synthetics, like certain types of nylon, there's thermomechanical recycling, sorting, melting it down, and remolding it, often with some virgin material added to maintain quality.
Okay, so mechanical recycling has its place, especially for certain waste streams and end uses. What about thermal recycling? Sounds like using heat. How do you turn clothes into fuel?
Exactly. Thermal recycling uses high temperatures to convert textile waste into energy sources, fuels, heat. The main processes are pyrolysis gasification, plasma arc gasification, and hydrothermal liquefaction, or HTL.
And the advantage here is?
A key advantage is that thermal methods can often handle more challenging waste streams, things that are low quality, maybe contaminated, mixed materials that are hard to recycle mechanically or chemically.
Okay, tell me about pyrolysis first.
Pyrolysis involves heating the waste in the absence of oxygen, typically 500, 700 degrees Celsius. This breaks down the organic matter into three main products: a solid char, a liquid oil, bio-oil, and a mix of gases called syngas.
And these products are useful?
Potentially, yes. The char can sometimes be used as a solid fuel or activated carbon. The oil can be refined into liquid fuels. The syngas can be burned for energy or used as a chemical feedstock. Researchers are even looking at using catalysts or different atmospheres like CO2 during pyrolysis to get more valuable gases like hydrogen.
Interesting. Any real-world examples?
There's been work on pilot plants converting things like lint microfibers from dryers into charcoal, oil, and gas, showing potential profitability in CO2 reduction. Cotton waste had been pyrolyzed to create chardsorbents used to remove heavy metals like chromium from water.
So turning one waste problem into a solution for another. Smart. What about the other thermal methods? Gasification.
Gasification uses high temperatures, but with a controlled amount of oxygen or steam. It primarily converts the waste into syngas. It seems particularly effective for polyester blends producing syngas and also valuable aromatic compounds.
Okay. And HTL, hydrothermal liquefaction.
HTL uses hot, pressurized water to break down the waste. It's quite promising for mixed textiles, like cotton polyester blends, because it can potentially convert them into bio-oil and recover valuable chemicals like terephthalic acid, a peat precursor, without needing extensive pre-sorting or color removal.
That sounds very useful for real-world mixed waste.
It does, and plasma arc gasification uses extremely high temperatures, like in a plasma torch, to break down waste into very simple molecules, mainly syngas. It's very efficient, but can be energy-intensive itself. So you see, thermal offers a way to get value from difficult streams, often generating energy or fuel products.
Got it. So moving on from heat, chemical recycling, how does that work differently?
Chemical recycling goes a step further, chemically breaking down the polymer chains in the textiles back into their original building blocks, the monomers.
Like taking Lego bricks apart.
Exactly like that. You get back the basic components, which can then be purified and repolymerized to create new, high-quality fibers or materials, essentially identical to virgin ones.
And the big advantage is
the potential for higher quality output, and critically, the ability to selectively target and separate different fiber types and blends, which is a massive challenge for other methods. Common approaches include hydrolysis, methanolysis, glycolysis, solvolysis, basically using chemicals, catalysts, heat, and pressure to break those polymer bonds.
What are some key examples for textiles? Cotton, polyester.
For cotton, which is cellulose, methods involve dissolving it using special solvents like in the lyocell process, or using things like ionic liquids or alkaluria solutions, and then regenerating new cellulosic fibers. Acid hydrolysis can break cotton down further into glucose, which could be a feedstock for biochemicals or biofuels. Researchers have even regenerated cotton fibers via wet spinning with properties similar to rayon, and sometimes even recovering and reusing the original dyes.
Okay, and for polyester PET, that's a big one.
Huge one. Chemical recycling of PE is quite advanced compared to others. Methods include methanolysis, which uses methanol to break PT down into dimethyl terephthalate, DMT, and ethylene glycol, EG, both monomers that can be used to make new PT. Glycolysis uses EG for a similar breakdown. Hydrolysis uses water, acids, or bases to break it down, potentially yielding terephthalic acid, TPA, and EG.
And this works for blends, too.
That's the potential. For example, you could use specific conditions, maybe an acid, to hydrolyze the polyester in a cotton-polyester blend while leaving the cotton relatively intact, or vice versa using an alkali. Ionic liquids are also being explored for selectively dissolving one fiber type out of a blend, like dissolving the cotton away from nylon.
It sounds incredibly versatile, potentially yielding really high-quality recycled stuff. You mentioned dye and water recycling, too.
Yes. Chemical methods can also help here. Some processes aim to separate dyes from the fibers during recycling, potentially allowing the dye to be recovered and reused. And advanced wastewater treatment, often combining chemical precipitation with multiple filtration steps like ultrafiltration, nanofiltration, reverse osmosis, is being used to clean textile processing water so effectively that it can be reused directly back in dyeing processes, saving huge amounts of water.
That's fantastic progress. Okay, one more category, biochemical recycling.
Using biology.
Exactly. This approach uses biological agents, typically enzymes or microorganisms, to break down textile materials.
How does that work?
Enzymes, which are biological catalysts, can be used to specifically target and break down certain polymers. For example, cellulase enzymes can break down cotton, cellulose. This is being explored for post-consumer textiles, including blends. Sometimes a pre-treatment, maybe alkaline, is used first to help break down the cellulose while preserving something like polyester. Enzymes can also convert the resulting sugars, like glucose from cotton, into other valuable biochemicals like lactic acid. What about microorganisms?
Microbes can be used in processes like fermentation. Solid-state fermentation is being investigated for decolorizing dyes in textile wastewater using fungi, for instance. Anaerobic digestion using microbes in the absence of oxygen can treat textile wastewater, often mixed with other organic waste, to produce biogas, methane, for energy, while also removing color and reducing pollutants.
So potentially a more natural or lower energy approach for certain things.
Potentially, yes. Biochemical methods offer sustainable routes, often operating under milder conditions than chemical or thermal processes, though they can sometimes be slower or require specific conditions.
Right, so we have this growing toolkit of recycling technologies. But recycling isn't the only answer in a circular economy, is it? What about just using things for longer? Reuse and repurposing.
Absolutely essential. Reuse and repurposing are arguably even higher up the circularity ladder than recycling because they keep the product intact, retaining more of its embedded value and energy.
So how do we encourage more reuse?
It involves extending the lifespan of textiles in their original form. Finding new owners through various channels, passing clothes down, selling or donating to consignment or thrift stores, clothing swaps, online peer-to-peer platforms like Depop or vintage charity drop-offs. Maximizing reuse directly reduces the demand for virgin fibers, saving all the resources and energy that go into making new stuff. Think about your own closet. How many items have only been worn a handful of times?
Guilty. And repurposing takes it a step further, right? Using it for something different.
Exactly. Repurposing finds a new function for the textile item, either by the original owner or someone else. This can range from informal things like cutting up old T-shirts for cleaning rags to more creative and structured approaches. Well, traditional crafts offer great examples, like Nakshi Katha embroidery in South Asia, where old saris are layered and stitched into beautiful new quilts or blankets. This not only reuses waste, but preserves cultural heritage and can provide livelihoods. These small-scale initiatives can really boost local economies.
And then there's upcycling, which seems very trendy now.
Yes, upcycling is a specific form of repurposing, where you transform waste materials or unwanted products into new materials or products perceived to be of higher quality or value than the original. It's about creative transformation. It aligns with reuse, but adds that value creation element, often making it more sustainable and even cost-effective than some forms of recycling.
So cutting up jeans to make a bag, maybe?
That's a classic example.
Yes.
Or using fabric scraps to create unique fashion pieces. Even things like using old textile packaging for other purposes, like cushioning, or processing it into non-woven fabrics. And community efforts, like that Hall for Humanity initiative in Bangladesh, show how organized reuse can support vulnerable populations while tackling waste.
These strategies feel really important for just slowing down that constant churn of new production. What about newer business models emerging around this, rescale and rental?
Yeah, these are getting a lot of attention. The rescale approach emphasizes building sustainable supply chains that include effective reverse logistics.
Reverse logistics.
Basically, managing the flow of products back from the consumer for things like repair, refurbishment, component harvesting, or proper end-of-life processing. It's about closing the loop systematically. And the economic argument is strong. Remember that stat about people potentially saving $460 billion collectively just by not discarding clothes prematurely? Given the average garment is only worn maybe 7 to 10 times.
Only 7 to 10 times? That's shocking.
It is. So models that extend that useful life have huge potential.
Which leads to rental models, like rent the runway, but maybe for everyday clothes, encouraging using, not owning.
Precisely. We're seeing more platforms emerge offering clothing rental as a service, often automated, sometimes focusing on eco-friendly cleaning and logistics. The idea is to give people access to variety and trends without the need for constant ownership and disposal. It directly challenges the fast fashion model by maximizing the use of each garment and then ideally channeling it into reuse or recycling streams afterwards.
Okay, so we see how circularity tackles the environmental side. But let's talk more about the connection to economic growth. Is this just about being green, or is there real money in it?
That's a critical point. The circular economy is increasingly viewed by policymakers, businesses, researchers, not just as an environmental strategy, but as a genuine pathway to economic prosperity and resilience.
So it's moving beyond just niche environmentalism.
Definitely. While sustainability traditionally balances environment, economy, and society, CE often leads with the economic and environmental benefits, assuming positive social outcomes will follow. Look at the EU's Circular Economy Action Plan. Key priorities include enhancing product durability, tackling microplastics, but also preventing greenwashing. They see it as core economic policy now.
Are we seeing hard evidence of economic benefits, specifically from textile circularity? It seems like a major selling point would be showing businesses they can actually make more money this way. Are there initial hurdles or investments needed?
Good question. We probably need more specific data from the core textile manufacturing sector itself. But studies in related areas, like composite manufacturing using recycled textile waste instead of virgin materials, have shown clear benefits. Cost reductions from avoiding virgin material purchase, eliminating landfill fees. One study suggested replacing over 40% virgin material with recycled could actually increase profitability. Of course, it depends heavily on the relative cost of recycled versus virgin materials at any given time.
Right, the economics have to work.
They do. And broader studies looking at circular economy factors across European economies, things like revenue from environmental taxes, overall recycling rates, investment in recycling sectors, found a positive correlation with GDP growth. So the macro picture suggests circularity can drive economic activity.
What about specific examples in clothing reuse?
There are interesting case studies. The Rotuna shopping mall in Sweden, which only sells repaired or upcycled goods, highlights both the potential and the complexities. Research is looking into optimizing supply chains for reused clothing to maximize lifespan and environmental benefits. And studies quantifying the impact of using secondhand clothes versus new ones consistently show huge savings in water, energy, and CO2. Stores like Humana in Portugal demonstrate positive environmental impacts alongside funding social projects.
It's really compelling how these models blend environmental, economic, and even social value. Now, how can technology like the Internet of Things, IoT, help accelerate this whole transition?
IoT is potentially a massive enabler for the circular textile economy. Its core strength is providing transparent traceability across the entire value chain.
How's that?
Imagine tracking a garment from fiber production through manufacturing, retail, consumer use, and eventually collection for reuse or recycling. IoT systems using sensors, tags like QR codes or RFID, connected databases can capture data at each step. This allows you to really know what a product is made of, where it's been, its condition, which is crucial information for effective circularity.
So it helps manage the complexity.
Exactly. It can help businesses verify the environmental and social credentials of their suppliers. It can provide consumers with detailed product history, maybe scan a tag and see the materials, where it was made, even suggestions for repair or recycling. This could influence purchasing decisions. Using secure, decentralized databases like blockchain could make this information durable and trustworthy.
What are some concrete examples?
We mentioned QR codes for lifecycle info, using standard database systems within an IoT framework for supply chain tracking. Blockchain for tracking carbon footprints stage by stage. Sensors during manufacturing could monitor quality in real time, potentially reducing defects and waste or providing data to predict lifespan. Detailed waste analysis from smart bins could inform recycling process design. Tracking product flow helps optimize collection, sorting, and redistribution logistics. And brands could use it to directly communicate their take-back or recycling programs to consumers.
It sounds like IoT could provide the crucial data infrastructure needed to make circularity work smoothly at scale. Now, we touched on the UN Sustainable Development Goals earlier. Could you just expand on that connection a bit more? How does textile circularity really help achieve those broader global goals?
Absolutely. The circular economy acts as a powerful engine for advancing multiple SDGs. It's not just about SDG 12, responsible consumption and production, although that's central. We'll think about SDG 1, no poverty. Creating jobs in new circular industries, repair, remanufacturing, resale, recycling, collection, and processing. Plus, access to more affordable, durable, reused goods helps lower-income households. SDG 8, decent work and economic growth, and 9, industry, innovation, infrastructure are clearly boosted by the new business models, technological innovation, and investment required.
Makes sense.
Reducing waste generation contributes to SDG 11, sustainable cities and communities, cleaner urban environments. The focus on resource efficiency and reduced pollution directly supports SDG 13, climate action, SDG 14, life below water, and SDG 15, life on land.
Right. Less emissions, less water pollution, less land use.
Exactly. And achieving this transformation requires collaboration, which links to SDG 17, partnerships for the goals, sharing knowledge, technology, financial resources between businesses, governments, researchers, and citizens. Ultimately, by fostering knowledge, education, and pro-environmental behavior, the circular economy approach helps build momentum towards achieving all the SDGs in the long run.
It's clear the potential is enormous. But let's be realistic. It can't be easy. What are the main roadblocks, the challenges and risks involved in actually implementing a circular textile economy?
You're right. It's definitely not a simple switch. There are significant hurdles. One is just the sheer volume of waste currently generated at all stages and integrating that effectively into collection and recycling systems.
The logistics alone must be daunting.
Immense. Then there's the economic viability of recycling itself. It's highly dependent on factors like the condition of the used item, the types of fibers and finishes used, the efficiency of the collection and sorting infrastructure, the market price for recycled materials versus virgin. It's a complex equation.
And product design needs a fundamental rethink, right?
Absolutely critical. Designing for disassembly, for durability, for recyclability from the outset. That's a major shift. It involves balancing aesthetics and performance with end-of-life options. Blended fibers are a huge challenge here. They offer desirable properties, but are notoriously difficult to separate and recycle effectively. You need innovative design teams who understand materials science and recycling processes and economics.
What about consumer behavior?
That's another big piece. We need effective disposal practices. People actually putting textiles in the right collection streams, not just the general bin. There's often lower consumer demand for recycled products, sometimes due to a perception of lower quality, whether justified or not, and generally public awareness about textile recycling lags behind things like paper, glass, or plastic. Mass awareness campaigns are needed.
And the recycling process itself has limitations.
Yes, inefficient collection and sorting, the variable quality of the incoming waste, those tricky blend fibers, incompatible with many current technologies. These all contribute to relatively low overall recycling rates. Currently, maybe 15–20% globally actually gets recycled back into textiles. Overcoming these requires concerted efforts from industry, research institutions, NGOs, everyone. We are seeing initiatives, though brands like H&M have collection programs, companies like Reblend focus on recycling tech. The European Commission has strategies.
So lots of challenges. What about specific risks for businesses trying to adopt circular models?
A thorough risk analysis identified several categories. Market risks, consumer resistance, uncertainty about demand for non-ownership models like rental, economic downturns hitting demand, supply risks, inconsistent supply or quality of recycled materials, higher logistics costs for reverse flows, lack of good data tracking, financial risks, uncertain revenues, high upfront investment for new tech or models, volatile prices for recycled versus virgin materials, higher operating costs initially.
Politics and regulations play a role too.
Big time. Political regulatory risks, lack of supportive policies or enforcement, absence of standards for circular products, sudden changes in incentives or tax laws, intellectual property issues with new tech, legal hurdles for rental service models, technical risks, shortage of skilled workers, quality control issues with recycled products, innovation risks, new tech might not perform as expected or might have negative cash flow initially.
And unexpected events.
Yes. The other category includes things like the COVID-19 pandemic, which massively disrupted supply chains and impacted supplier-customer financial stability. Two risks that consistently came up as highly impactful were product quality and customer perception.
It's a sobering list, highlighting that this transition needs careful management. Given all this, where should future research efforts be focused to help overcome these barriers?
Continued research is absolutely vital. We need to keep refining the technologies, but also focus on integrating CE principles throughout the value chain and, crucially, engaging consumers more effectively.
Any specific underexplored areas?
Several promising avenues. One is looking deeper into formalizing and scaling up traditional reuse and repurposing practices, like turning old clothes into handcrafted items, nakshikatha, doormats, etc. This could create significant business opportunities, particularly empowering women in places like Bangladesh, directly supporting SDGs.
Taking traditional wisdom and making it a modern business model.
Exactly. Another area is exploring the potential of regions like Africa. Many countries there have existing cotton industries and are geographically closer to major European consumer markets than current Asian manufacturing hubs. Could they become centers for large-scale repurposing and recycling of textile waste, creating local economic value and reducing the huge logistical footprint of shipping waste globally?
That's an intriguing thought.
And fundamentally, ongoing research must focus on improving the cost-effectiveness of all these recycling and reuse processes. For circularity to be truly sustainable in the long run, the economics have to work without constant subsidies.
This has been an incredibly thorough deep dive. To wrap things up, what are the absolute key takeaways you want people to hold on to?
I think the main thing is that transitioning to a circular economy in textiles isn't just a nice-to-have environmental goal anymore. It's becoming an environmental imperative and a really significant economic opportunity.
Right.
By embracing reduce, reuse, recycle, we can drastically cut waste, conserve precious resources, and actually create new economic value through innovative business models, recycling tech, reuse platforms, rental services.
But it's not without its difficulties.
No, absolutely not. We have to acknowledge the challenges and risks, technological, economic, logistical, behavioral. But these aren't insurmountable. They require collaboration, investment, policy support, and continued innovation from everyone involved: producers, consumers, governments, researchers.
So a final thought for everyone listening. As you go about your day, maybe take a moment to think about the clothes you're wearing, the ones in your closet. What's their story? How long will they last? What happens next? Consider the potential for more circular choices in your own life, from how you buy to how you eventually let go of things. There's tremendous hidden value locked up in textile waste, and unlocking it through circular thinking holds the key to a much more sustainable and potentially prosperous future for fashion. Thanks for joining us for this deep dive.